Okay guys, today we're in section 9.2 and we are simplifying square roots. The purpose of this is that not all roots are perfect squares like you worked on yesterday. Okay, you could tell that some of them that you put into the calculator you would get a decimal for. Well, we need a better way to write them than decimals because decimals, of course, are shortening that number and you want to make sure you're using the exact number all the time. Now, there's two ways to do this, and you can use whichever method you're more comfortable with. There is the tree method, which is probably more popular. And there's the perfect square method. Now, I'm going to try and show you both ways, okay? We'll kind of bounce back and forth and do one way and one the next way. We're going to start off with example 1. And example 1 gives me the square root of 180. So I'm going to show you using tree method first. Okay, tree method says that you take the smallest number out of 180 until you get to a prime number. Okay, so we kind of put it in a sideways box, like an L. The smallest number I can take out of 180, and it has to be the smallest, you have to go in order, is 2. Okay, what's left? Well, 180 divided by 2 is 90. Then I'm going to do it again because 90 is not prime. Smallest number I can take out of 90 is 2. That leaves me with 45. Smallest number I can take out of 45, well, I can't take 2 out, but I can take 3 out. 45 divided by 3 gives me 15. Smallest number I can take out of 15, I can take 3 out, and that leaves me with 5. 5 is prime. Okay, now since I'm dealing with a square root here, I'm looking for groups of 2 numbers. So I have a group of 2 numbers here. I have a group of 2 numbers here. This guy is left all by himself. He doesn't have a partner. Okay, now these 2 guys, since they have partners, they get to come out to the front of the root, and they get to be represented by one number. So you'll have a 2 out front. You'll have a 3 out front. And I know that seems kind of silly because you're saying you had 2 here. But remember, that was a square root. So you only want 1 out front to represent that. So this represents this pair. This represents this pair. He didn't have a partner, so he has to stay inside. Now I can clean that up. 6 square root of 5. That's tree method. Okay, now let's do that again, but this time let's show it with perfect square method. Now for perfect square method, I want to take the biggest perfect square out of 180. So if you go through your perfect squares, okay, 1, yeah, 1 will come out of 180, but it's not going to change it. 4, well, 180 divided by 4 would be 45, so we know 4 works, but let's see if we can get bigger than that. 9, 180 divided by 9 would be 20. Okay, so already we've beaten 4. Bigger than 9, 16. Does 16 come out evenly? No, that's a decimal. 1, 4, 9, 16, 25. 180 divided by 25. No, that's a decimal. Okay, 180 divided by 36. That works. And it leaves me with 5, okay? Well, 5's prime, so you know nothing else is going to come out of that. So that's a pretty good idea that 36 is the biggest perfect square that will come out of 180. So what we're going to do is we're going to split 180 into its perfect square, and then what was left? 180 divided by 36 was 5. Now we can clean up this first guy because we know what the square root of 36 is. He's he's a perfect square. The square root of 36 is 6. And then leave your prime guy alone, 6 square root of 5. Now, you have to know your perfect squares to be able to do this effectively. If you are somebody that's struggling with your perfect squares still, then this one's going to be a little more difficult, okay? That's why it's so important to memorize these because see how quick this was in regards to having to do this long old table? Okay, so perfect square method is actually the quicker way. But like I said, I will accept both methods. It's your choice. Okay, so let's do example 2. Example 2 gives me the square root of 24s squared. So now we've got a variable involved, but let's take care of the square root of 24 first. And again, I'm going to show it both ways. So on the left-hand side, I'm going to show tree method. Put that 24 in your box. Smallest number that can come out of 24 is 2. That leaves me with 12. Smallest number that can come out of 12 is 2. That leaves me with 6. Smallest number that can come out of 6 is 2. That leaves me with 3, and 3 is prime. Now remember, because we're dealing with square root, we want groups of 2 numbers. So we've got a pair of 2's there. He doesn't have another 2, and he doesn't have another 3. So that means a group of 2's, remember he represents 2 2's, come out front, and then the guys that don't have partners, 2 and 3, have to be left inside this time. So final answer would be 2 square root of 6. But don't forget these s's. I still have s squared inside here. Now remember what we said here. To be able to come out, they had to be in groups of 2. Same goes for variables. To be able to come out of the house, out of the root, there has to be at least 2 of them. Well, we have 2 s's. That means we have a group of 2 s's, so you could bring him out front. There's none left inside. Remember, this guy standing out front represents 2 s's inside. Okay? Now let's show perfect square method. So if I look at 24, I want to find the biggest perfect square that will come out of 24. 1 isn't going to change it. 4 gives me 6. That goes in evenly. The next perfect square would be 9. 24 divided by 9. No, that doesn't go in evenly. 16, 24 divided by 16, that doesn't go in evenly. And then I'm up to 25, which is larger than 24, so I don't want to pick him. Okay, so the largest perfect square would be 4, and 24 divided by 4 is 6. Then if I clean that up, square root of 4 is 2. Square root of 6. Don't forget your variables. Remember we said we needed 2 s's to come out. We have 2 s's. So there's my final answer. Okay. Now they're going to try to make it tricky on you because they're going to throw fractions in. But don't worry about that. Example 3 gives us the square root of 13 over 36. Now, as soon as I see this fraction in a radical, I just split it up to this. Let's take care of the square root of 13. Let's take care of the square root of 36. Well, what do you guys know about 13? 13's prime. So you couldn't do tree method on him, and you're not going to be able to do perfect square method on him. Right from the beginning, he's simplified. There's nothing else you can do for him. And what do you notice about 36? 36 is a perfect square. You should know what the square root of 36 is. 6. There's my final answer. I didn't need to do tree method on either one of those because 13 is prime. That means I can't do anything there, and 36 was a perfect square. Okay? Now, let's use this. Let's keep going on checkpoint. Checkpoint number 1 gives us the square root of 63. Okay, I'm going to use tree method on this one. So, 63, smallest number that can come out. 2 won't come out. 63 divided by 3 would give me 21. Smallest number coming out of 21. 2 can't come out. 3 can. That would leave me with 7, and 7's prime. Now remember, I'm looking for groups of 2 numbers. Here's a group right here. This guy doesn't have a partner. So that means 3 gets to come out front. 7 has to stay in the house. 3 square root of 7. Let's look at checkpoint number 2. We have the square root of 54t squared. Now ignore those variables to begin with. Let's take care of square root of 54, and I'm going to do perfect square method this time. So I'm looking for the biggest perfect square that will come out of 54. All right, if I try 1, yeah, it's not going to change it though, so I don't want to deal with him. How about 4? 54 divided by 4? No, that's a decimal. 1, 4, 9. 54 divided by 9. That works. That would leave me with 6. Let's make sure I can't take anything else out. 54 divided by 16. No, that's a decimal. 54 divided by 25. Another decimal. 54 divided by 36. Another decimal. 54 divided by 49. Another decimal. And my next perfect square would be 64. That's bigger than 54. So I can't do anything else here. We took the biggest perfect square out, 9. 54 divided by 9 is 6. Now let's clean this up. You know what the square root of 9 is? 3. Square root of 6. Now let's take care of our variables. Remember, to come out of the house, they have to be in groups of 2. We have 2 t's here. That means they can come out as one group of t's. No one is left inside the house except that 6. There's my final answer. Okay. Checkpoint number 3. We've got a fraction, square root of 15 over 16, sorry. So go ahead, I like to write this as square root of 15 over square root of 16, and I'm going to simplify these separately, okay? Let's do tree method for the top. Smallest number that'll come out of 15, 3. That leaves me with 5, and 5's prime. But notice neither one of those has a partner. Neither one of those has another 3 or another 5, so that can't be simplified. He'll just get carried across. Then take a look at the bottom. What do you know about 16? 16 is a perfect square, so we should know the square root of 16. The square root of 16 is a positive 4. There's my final answer. We simplified the top, we simplified the bottom. Last one for checkpoint, number 4. Another fraction. They give us the square root of 32 over n squared. Go ahead and rewrite this as 2 roots. Square root of 32 over the square root of n squared. So let's try to break down 32, and we're going to use perfect square method. The biggest perfect square that will come out of 32. 4 comes out. 9 does not. 16 will come out, so he'll beat him. 25 will not come out, and then that brings me to 36. That's bigger than 32. Notice how I'm just going through those perfect squares. 1, 4, 9, 16, 25, 36. That's why it's so important to memorize those so that I can just zoom through that and see which ones will go into 32. So this will split up into the square root of 16, and then what is 32 divided by 16? 2. Now I can clean this up because I know square root of 16 is 4. Square root of 2. Let's go ahead and write him up here. When I go to clean the bottom up, all I have is variables. Remember, they have to come out, since it's a square root, they have to come out in groups of 2. He has 2 n's, so that means a group gets to come out and no one is left inside. Remember, by taking this guy out front of the radical, he represents 2 n's that were inside the radical. So no one is left. I don't even need to write that radical. Okay? All right, let's turn the page. Look at page 460. Page 460. 460, we're going to look at numbers 3 through 6 in skill check. So let's take a look at number 3 first. Number 3 gives me the square root of 12. I think it's tree method's turn. So smallest number that will come out of 12 is 2. 12 divided by 2 is 6. Smallest number that will come out of 6 is 2. 6 divided by 2 is 3. Looking for groups of 2, I have one right here. He doesn't have a partner, so he's going to have to go back in the house. 2 gets to come out front. 3 is in the house. Okay. Number 4. Let's practice perfect square method. 4. Yeah, I could take 48 divided by 4. He works. 9. 48 divided by 9. No, that won't work. 16. 48 divided by 16. Yeah, that could work, so that beats him out. 25. No, 48 divided by 25. That's not even. Or that doesn't come out evenly. 36. No, that's a decimal. And then I go to 49, which is bigger than 48. So the biggest perfect square that will come out of 48 evenly is 16. And 48 divided by 16 is 3. Now I can clean this up. The square root of 16 is 4. Square root of 3. Okay, number 5. We have the square root of 81 over 4, and I'm immediately going to write that into the square root of 81 over the square root of 4. Now, guys, what do you recognize about both of those numbers? 81 and 4 are perfect squares. You don't need a special method for this. The square root of 81 is 9. The square root of 4 is 2. Boom, you're done. Recognize those perfect squares. If you have to write them at the top of your page every time, do it so that you can pick them out for this. Okay? And last one, number 6. We have the square root of 7 over 25. Go ahead and write that as 2 separates. The square root of 7 over the square root of 25. Now they're being easy on you here because what do you know about 7? 7's a prime number, so it doesn't matter what method you use. He's not going to be able to be broke down because he's prime. And what do you notice about 25? 25 is a perfect square. He's in your list. Square root of 25 is 5. There's my answer. So I didn't have to do tree method or perfect square method on that one. Okay? All right. You can practice some from here. Good luck on your homework.